Hi, in this part we're going to look at angles and parallel lines. Just to recap from previous video, the thing we're going to be using today is basically two things. First things first, if your two lines that crisscross each other, then the opposite angles will be the same. So if this is 40 degrees, then this will also be 40 degrees. And lastly, don't forget that also forms a straight line here. So because these two together make a straight line, they must add up to 180, which means in this case this will be 140 degrees, and also so with this because it's opposites, they must be the same. Okay, let's get started. All the rules we're looking at today are going to use parallel lines. That is two lines that point in the same direction, and that will be shown to you by these little arrows here. That shows that these two lines point in the perfect same direction. Okay, that basically tells us one piece of information that turns out to be really important. And that is that these two angles here will always be equal. And it seems quite easy. If I just drag down this top line, you can see it's always going to go perfectly over the second line. And again, it doesn't matter which angle you're referring to, when you drag the two lines together, they'll always be exactly the same. Okay, and also, if I move this line around, that's not going to change anything either. The only important thing here is we have these two parallel lines. Again, once you've got that, that means these two angles here, when you shift them down, will always be the exact same angle. Okay, let's see how we can use that. So first question, fairly basic. If we zoom in, we can see if I basically shift this angle down, right now it's kind of on the right hand side of this cross. If it goes down to the other parallel line on the right hand side, these two angles must be exactly the same. So here x must be 61 degrees. Moving on, we can do the same rule here. So I've got two parallel lines, which means I can basically go from any of these points down to any of these points. My 37 is here, that's based on the top right. So if I shift it up to the next crisscross point, that means the top right angle will be the same. That will also be 37 degrees. Again, like you saw in the animation, you can imagine this line moving up and sitting perfectly on top of this line, which means this 37 will then go to this space here. Okay, now we know this is 37, we can work out x really easily. In this case, you have opposite angles. So because these two are opposite one another, the angles must be the same, so x will also be 37 degrees. Okay, another example, just running with the exact same idea again. We know this angle is 100, so let's see if we can move it down to basically the other, we'll call it crossroads for the time being. So here I'm on the right hand side is 100 degrees. If I go down here, that's going to basically move to this point here, so this angle is also 100 degrees. Again, you can imagine this line sliding down, and this 100 will now become here. We can now work out x. We can do that because we have two angles on a straight line. We know these two combined must give me 180. So if this is 100, then x must equal 80, so that when you add them together, you'll get a total of 180. I'll just do one more simple example, and then we'll look at the harder questions. So this is always the same idea. Look at the angle you've got, work out whereabouts it is. So here I'm going to say top right. And if we shift down to the other crossroads, that means that top right angle must be the same. Again, if this point shifted down, there would be the same angle. So this is 43 degrees. Now we have an opposite angle, so these two are going to be the same. So x will also be 43 degrees. Okay, that's the most simple look of questions. We've only got two parallel lines and one cutting through them. We're going to look at a couple examples where it gets a bit more hairy than this. So you've got to be really careful that you basically move your angles in the right way. So to make the rule really clear, the rule basically states you can only move from one parallel line to another parallel line. So for example, if I start here, it's on this parallel line. I can only move this 120 degrees across so that this line is still parallel. So the 120 can go to here because these two lines are parallel. Okay, that's what you're looking for. What you cannot do is move it up, because if I move it up to here, these two lines are not parallel. They're pointed in different directions, which means that rule will not work. Okay, which is why these two angles are different. Okay, but we can move along the parallel line, which again helps us straight away work out some angles. That means y must be 120 degrees, has to be the same. We've now got a straight line here, so y and x must add to 180, and that means x must be 60 degrees, because 120 plus 60 is 180. And now I need to find z still. Again, I can't go up here, because I don't go from one parallel line to another parallel line, but I can use this 71. These two lines are parallel, which means I can go from this parallel line to this parallel line, which means this will also be 71 degrees. And now we can work out z. Okay, we've got opposite angles, so z will also be 71 degrees. Just one more, or just two more examples, sorry. This one, I'm going to start off by finding x. So occasionally these questions, these points will form a nice triangle. And we've seen before how you can work out angles in a triangle. We know they must add up to 180. So we add together the angles we've got so far, which is 110, and we then do 180, take away that number, which means x must be 70 degrees. So we found one angle there. Let's see what else we can find. Okay, y and v both look fairly easy to find. Okay, for y, we know it's opposite the 60 degrees, so y must also be 60 degrees. For the v, we can see a straight line here. We know straight lines always add up to 180, so we do 180 take away 50, and that'll be what v is. That comes out at being 130 degrees. Okay, we've still got some angles to work out, but you notice now we've got this pair of parallel lines. That means I can basically move from here to here and from here to here. Again, you can only move from one parallel line to the other parallel line. So I can just do this straight away actually. I know this angle here is 60 degrees, and if that moves across, that will take the exact place w takes. So w must also be 60 degrees. And for z, if I look over here, I know this angle is 130 degrees, and because they're both in the same place relative to this sort of crossroad point here, that means z will also be 130 degrees. And that's it, that's pretty much as hard as it's going to get. I'll show you one more example, because occasionally they just want you to work out one angle, and it's a bit daunting to think, well, how do I work out x from that information? The basic rule of thumb, the best advice I can give, is just work out any angles you can. So if we look at this 97, we can actually straight away work out every single angle around there. We know the opposite one must be 97. I've got a straight line here, so these two add up to 180. So I do 180 take away 97 degrees. That'll give me this angle here. That is going to be 83. So this angle is 83 degrees. And then we have another opposite line. So this angle here will also be 83 degrees. And that's a good place to start. I just found some angles. I'm going to hope it's going to be useful. Okay, moving on. From the last example, we used the fact there was a triangle. So we're still at the same triangle shape here. So if you always sort of spot triangles, that can make your life a lot easier. So for this triangle, we can work out the third angle, because all three must make 180. So we've done so many times now. We're going to add together the angles you've got. In this case, they add up to 130. And this missing angle will be 180 minus that total, which is 130. So therefore, this angle is 50 degrees. Okay, and while I'm here, I can also work out these angles. That's 50 degrees. This is a straight line, so I do 180 minus 50, gives me 130 degrees, and this is also 130 degrees. Okay, so now I've got quite a few angles, and hopefully when you're doing that, you can see we've kind of got slightly closer towards x. And what you can hopefully notice now is we can use this pair of parallel lines. So I can go from anywhere around this point to anywhere around this point. So if I look here, this x is in the same place as that 130 degrees, so therefore x must be 130 degrees. So if the question we don't have too much information or too many angles to work out, just work out anything you can and it will be helpful. It will either get you marks or get you closer towards the answer. That's it. You have some questions to try. There's only 8 of them. The first 6 are quite straightforward. The last 2 get a bit more challenging. Good luck and thanks for listening.